Good day, everyone. My name is Professor Kazim Adepoju. Today, I just want to, there have been a kind of methodological disputes, between the use of statistical models, okay, and, you know, the machine learning algorithm. Okay, I think part of my work, part of what I want to do today is basically to, trying to be able to shed more light, okay, on this. Okay, I'm going to say this by profession, or let me just say by qualification. Of course, I'm going to say I am an expert in statistics. And at the same time, an expert in machine learning. And of course, I've looked at it too. And I was able to, differentiate, I was able to figure out the difference between the two. Okay, so, you know, choosing one uh, algorithm against the other one, depends on, the kind of uh, maybe your objective, okay? The fact remain that if we really want to understand the world, we basically need to, you know, collect data. And when we collect data set, cause the information that we need, okay, is not readily available in the data set. So which means something needs to be done to be able to have access to the information. Okay. So it's more or less like I get a soda now, like maybe a Coke, and maybe if I want to drink that, of course, I don't have access to the liquid contents in it until something needs to be done. Maybe I got to open it. And of course, what I actually need is the liquid content. And the moment I'm done, of course, the bottle, okay, or the can will actually go into a trash. Or maybe you may also want to recycle that. Okay, so that is a typical, the way data actually look in the recent, because the data said that we collected from the field of inquiry, they are basically contaminated. And what we're trying to do is to filter out the noise, to be able to have access to the information. Why do I need information in the first place? I need information in the first place because the existence of reality is independent of my knowledge. Okay, I want to be secured in my environment. When I talk about environment, maybe I really want to understand my economic environment, or I want to understand my social environment, psychological environment, the medical environment, and so on like that. Okay, and for me to be able to do that, okay, I need information. And it is this information that will translate to the knowledge. Okay, the moment I get the knowledge, then I'll be able to know, okay, what to do concerning my environment. I'll be able to understand my environment. Okay, so because of that, we basically have what I'm going to call two major objectives. Okay, when we actually uh, have data set at our disposal, we may basically want to pursue what I call an explanatory goal. Maybe we got some set of variables, right? One is dependent, the other ones are independent, right? And we basically want to look at the effects of some variables, on a particular variable. Okay. Now, when you take a look at that, now I'm actually pursuing an explanatory goal. Okay, that's an explanatory goal. That's what we call a causal goal. Okay, and of course, the people in, the statisticians, the economists, psychologists, sociologists, and the scientific community in general. That is exactly what they always want to do. Like, trying to understand what has happened. Okay, which means they basically want to go retrospective, like, going backward. Okay. And, that is kind of synonymous with, well, that is synonymous uh, basic science. Okay. We're talking about basic science. The basic science is like, trying to understand the world. Okay. And, you know, if you understand the world, you can explain the world, right? Okay. The fact that you can explain the world, you can understand the world, does not really translate into the fact that you can make a prediction of the future. There's a difference between the two. Okay. So, we have applied science. On the other hand, the applied science is now going to say, okay, putting into consideration, okay, uh, our understanding of the world. Okay, can we have a way to make a prediction, okay, about the world? Okay, which means we actually want to pursue what I call a predictive goal. There's a difference between, like I said, there's a difference between pursuing an explanatory goal and a predictive goal. This have actually been argued, by statisticians like me before, that, the moment my model can do the job of explanation, the model can also do the job of prediction. Let me tell you, I don't argue that, but the fact remains that is basically, when, a model that is doing the job of explanation, if you use that kind of model for prediction without paying more attention to the nature of your data set, okay, this time around, I'm talking about big data, okay, talking about data with or maybe like thousands of independent variables. Of course, there's basically going to be a problem using statistical model, because the thousand with several form of variables, explanatory variables in that kind of situation, using statistical model, okay, in when, pursuing explanatory goal in that regard, you except you basically want to pull down all the variables to the most relevant one. You get what I mean? What if in a situation where, I know some of you may want to argue about the use of regularization, like lasso regression, the ridge regression, and the like, that would prune down the explanatory variables to the relevant one. What if in a situation where you got like 1,000 explanatory variables and maybe 500 of them are relevant? Statistical model will struggle with that. So the only thing we can do in that situation, we should actually forget about looking at the effects of some predictor variables. Okay, the only thing we can just do is what is a combination of independent variable that I'm actually going to use that can lead to the best prediction. The best prediction, it means you are pursuing a predictive goal. Okay, in a situation where we got a lot of explanatory variables, okay, of course, the idea of machine learning is going to, it's going to make sense, because with machine learning, that cannot answer a question of model explanation. Okay, the machine learning algorithm will answer a question that has to do with model prediction. Okay, for instance, I'm going to bust your bubble now. When you actually have a lot of variables in statistics, right? And we actually want to use, want to investigate, what is it called? The effect of these variables on a dependent variable. We do a lot of model selection procedure. We actually, we could use a stepwise regression, maybe either the forward or the backward or the stepwise, or we can even use lasso regression, the modified, or we use ridge regression. Why are we doing that? We are trying to prune down. We're trying to make sure that the regression parameter is relatively small, because it is when if you have a lot of variables in your model is going to capture noise. Okay, there's basically going to be what I call overfitting. We all know that. even though in statistical, when we're using the idea of statistical theory, okay, and we know that we want to estimate the regression parameter, they become estimator, right? And believing that the more explanatory variable that I add in my model, I'm actually going to reduce bias, right? The bias is going to be going down, but you are increasing the variance, okay? When you actually make an attempt to reduce bias, you're basically going to blow up the variance. And when you blow up the variance, your model is basically going to have a problem of overfitting, okay, which means your model is basically going to perform excellently with the training data set, but it's basically going to perform poorly with the unseen data or with the test data. You know why? Because your model has captured noise, okay? Because you try in a way, you are increasing the numbers of explanatory variables in your model because you basically want to reduce bias, because the bias is the major enemy, okay, of a statistician, of everyone in the scientific community. They basically want to reduce bias. But the fact remains that when you are making attempts to reduce bias, you're basically going to create another problem. Okay, well, so why can't we now have a way, or why can't we define our intention to the world? What are we trying to do? If I basically want to make prediction, okay, and I got a lot of variables, okay, I mean a lot of independent variables, particularly in the case of gene sequencing, of course, it is better to go with the machine learning algorithm. Okay, but if my intention is to actually if I'm pursuing a course I goal, I basically want to look at the effects of some variables on some variables. Of course, if I don't have high dimensional, if the variables are not really merged, of course I can actually resort to statistical means of seeking redress, where I can use the idea of regularization. I can use the model selection criteria, trying to prune down, okay, my numbers of variables, because the model explanation is going to make sense only if you have few numbers of parameters. What leads to few numbers of parameters is when you have few numbers of explanatory variables. I'm going to bust your bubble now. Do you know that multiple collinearity is not a problem with prediction? Yeah, multicollinearity. A model, could have a multicollinearity issue, okay, and still give the best prediction. Okay, where I can argue that with you with evidence. Okay, and another thing is, that when you are pursuing an explanatory goal, that I call it causal goal, then multicollinearity is an issue. You know why it's an issue? Because situation where you got a lot of independent variables, some of them may be correlating. Some of correlating mean they may be given the same statistical information, and because of that, there's going to be issue. So multicollinearity is only it's only an issue when you are pursuing an explanatory goal, when you are trying to know what are the effects of this on that. But when you are pursuing predictive goal, we don't talk about multicollinear. It's not an issue. And that is why in machine learning algorithm, when you're using the machine learning algorithm, we realize, they don't care about all those assumptions. And the model will still give a fantastic result, which they use in the, advanced world. They see the results. You get what I mean? So, what statisticians are doing now is there a way we can actually improve the predictive power of statistical model? What I'm trying to say right now, the predictive power of a statistical model, okay, compared to the machine learning algorithm in the case of big data, okay, statistical model does not, has a very low predictive power compared to machine learning algorithm when you're talking about, the big data. I'm not trying to say that we don't use statistical model to make prediction. Of course we do, but it's going to have a low predictive power. That's what I mean. That can be argued. But my takeaway from today, well, from what I just presented today is, you know, depending on the nature of my data set, okay, depending on the nature of my data set, okay, and my intention. If I want to make prediction, if I'm not interested in what is the role of this explanatory variable on the other one, okay, if I'm only interested in prediction and I got big data, then we should go for machine learning algorithm. When use machine learning algorithm like KNN, okay, like decision tree, random forest, okay, and so on like that. There's a lot of them. But if my intention is to make maybe to look at the effect of the effect of, or maybe the effect of this variable on the other variable, then the best way to go by that is using statistical model. Okay, so what distinguishes between using the machine learning algorithm and statistical model is the nature of your data. Some of you may want to argue it out, like, okay, in statistics, we also have a large sample size. Like, if you want to argue from the point of view of central limit theorem, don't forget the central limit theorem was only focusing on the sample size. The central limit theorem was not really talking about the dimension. I mean, the numbers of variables, independent variable, again, the number of observation. Even if you want to go by Gauss-Markov theorem, when the number of observation is less than the numbers of predators, I mean the numbers of explanatory variables, there's going to be problem with the Gauss-Markov theorem. Okay? So the right thing to do is, choosing between statistical model and machine learning algorithm. It actually depends on the nature of your data set. When I say nature of your data set, do you have what I call a dimensional data set or not? And not only that, what is your intention? Do you basically want to make a prediction? Do you have a predictive goal, or do you have explanatory goal? Okay. And when you are pursuing an explanatory goal, of course, we're going to be focusing on average effect. Anything that has to do with your pursuing explanatory goal is always based on average. But if you are pursuing a predictive goal is not based on average. You are predicting on individual level. Okay? The prediction is always made at individual level because the prediction is forward looking. You get that? Why, when you are pursuing an explanatory goal where you basically want to, understand what has happened, okay, you are going retrospective. That's what I mean. Okay, more information, still coming on, this topic. Okay, see you later. Bye for now, everyone.